This section will cover double angle and half angle identities. So let's start out with the sum and difference identities. And luckily, none of them have to be memorized. You are going to be allowed to use a trig identity sheet for the exam. I will have that posted in D2L in the exam review file, and it will include these. So that's awesome. So the sum and difference identity for the cosine function is this one. Here's the one for the sine function, and here's the one for the tangent function. Now at this point, you're probably wondering, why do I need this? And the biggest part is that this will actually help us to be able to evaluate without a calculator certain values. So let's continue. Okay, now let's look at the double angle identities, and these are also on your trig identity sheets. So for the sine double angle identity, there's only one formula, but for cosine, there's 3 different options that you can choose from. And I just recommend using the one that makes the most sense given the material that you have. So for example, if we were asked to find the sine of 2 theta, right now, before we had these identities, we wouldn't really be able to evaluate that. You can't just double what the sine formula is, or what you get for the sine of theta. So what we have to do is we have to use this formula. So the sine of 2 theta equals 2 times the sine of theta times the cosine of theta. Now, I do know what the cosine of theta is. The cosine of theta is negative 2/5 because they told me that. But what I need to figure out is the sine of theta. So if I know the cosine of theta is negative 2/5 and that theta is between pi and 3 pi over 2, that means I know I'm in that third quadrant for theta. So when I take this, cosine of theta equals negative 2/5, that means I know that my x value is 2, my r value is 5, and I can figure out that y value. So x squared plus y squared equals r squared, which is 5. So 4 plus y squared equals 25. So y squared equals 21. So y equals the square root of 21. So when I go to write the sine of theta, so that means the sine of theta equals, so again, if we're in this third quadrant, sine is going to be negative because sine deals with the y value, and then it's y over r, which is 5. So this would be negative root 21 over 5. So when I multiply these out, so we can turn that into a fraction, you just multiply straight across. So we've got 2 times negative root 21 times negative 2 for the numerator. So that gives us positive 4 root 21. And then in denominator, we have 1 times 5, which is 25. And that will not reduce any further. For the cosine of 2 theta, I could use any of these formulas. What I'm going to choose to use is this one, and that's because this only requires that I know what cosine of theta is, which they gave me. I did figure out what sine of theta is, but I could have made a mistake, and you don't want to obviously use a problem that you've messed up on for a value. So I usually, if I can use a formula with the given values, that's what I use. So I'm going to choose to use this one to evaluate the cosine of 2 theta. So cosine of theta is negative 2/5, and I'm squaring that. So that's going to give me 2 times 4 over 25 minus 1. So make that a fraction. 2 times 4 is 8. 1 times 25 is 25. So now let's get a common denominator. Multiply both the top and bottom of this one by 25 over 25. So I get 8 over 25 minus 25 over 25, which becomes 8 minus 25 is negative 17 all over 25.